In this video, we will present one of the functions of the data link layer. The data link layer's name in French is couche de liaison de données. The data link layer has different functionalities. One of them is called frame synchronization. The objective of this function is to separate bit stream that is received by the physical layer into frames. Let us see why this is needed and how it works. In this particular video, we are going to look into only one technique that is used for frame synchronization. In subsequent videos, we will be looking at two other frame synchronization techniques. The need for frame synchronization is shown in this slide. The layer 2 entity on the left is producing a series of frames. One of them's 10, we're showing here the bits, 10, 1001, and 110. These frames are being passed to layer 1 on the left system. Layer 1 will take the sequence of bits and will transmit those bits over the physical channel, which could be of any kind. So it could be fiber optics, twisted pair, or it could be any other type of coaxial cable or any other medium like the air, using electromagnetic waves, for example. As you can see on the bottom, the sequence of bits, which is green in the slide, represents the sequence of all three frames. So it starts with 10, it continues with 1001, and finally the last frame, 110. Since the unit of transmission of layer 1 is the bit, all of these bits are going to be transmitted one after another, and there is no separation between them. So the layer 1 entity on the right will receive all of them and will not know how to separate them into the frames that were actually passed to layer 1 on the left system. Therefore, a technique needs to be devised to separate these bits back into the frames that are going to be passed to layer 2. Layer 2 is responsible for designing and applying the technique. What we'll look at now is the technique that is called character count, which is the first one in this slide. There are, however, many techniques, and a further two techniques, one called byte stuffing and the other one called bit stuffing, will be presented in subsequent videos. So let us concentrate on the first one here, character count. The character count adds a header to each frame to convey information on the number of characters in that frame. Let us see how that works. This is perhaps the simplest frame synchronization technique. What is done here, and you see two figures, one on the left and one on the right of this slide, the left one being just an example. It shows in blue the header that has been added by the data link layer. This header contains the number 5 because the resulting number of characters in this frame will be 5, including the header. You have 5 CHTX. The character count is therefore 5. As you can see on the right, this technique allows you to actually separate a sequence of bits that can be arranged into a sequence of characters if you have a character-based transmission system into the different frames. You can separate the frames out as shown here from frame 1, which contains 3 characters, to frame 4, which contains 6. But what happens if there is a bit error in one of the headers? If one of the frames, for some reason, due to electromagnetic noise or any other reason, has an error, the result is the following. Here on the top, you see the frame without errors, and on the bottom, you see an error, for example, that will make the system read the 5 as a 4 in the second frame. And what ends up happening is that the borders, the frontiers between the different frames get actually shifted, and the error will propagate. So once one frame is in error, all subsequent frames will be in error, or at least until by coincidence you end up having the appropriate boundary. This slide contains an exercise that I would like you to do. You can pause the video so that you can read the exercise carefully, and you can always ask me questions if you don't get the answer or if you have trouble understanding the statement of the exercise. In the next video, we will be looking at character stuffing, which is a second technique for frame synchronization.